Good morning, ma'am. Good morning, classmate. Our lesson for today is all about rotation. Lesson 3, rotation with variable angular acceleration. In the previous lesson, we learned the different formula of the rectilinear and rotation. Since the differential equation of the rectilinear motion and the rotation are mathematically identical, we need to observe merely that the technique for handling the case of rotation with a variable angular acceleration is identical to the developed in rectilinear motion with variable acceleration and motion curves. So, rotation is the motion of the rigid body in which the particles moves in circular paths with their centers on a fixed straight line called the axis of rotation. The plane of the circles in which the particles move are perpendicular to the axis of rotation. So, in ang example number 2, a body rotates according to the relation alpha, or the angular acceleration, is equals to 3t squared plus 4. Displacement of being measured in radians and time in seconds. If its initial angular velocity is 4 rad per second, and the initial angular displacement is 0, compute the value of omega, or the angular velocity, and theta, or the angular distance, for the instant when t is equals to 3 second. Solve analytically. So the given is ang alpha, or the angular acceleration, is equals to 3t squared plus 4. Ang iya ina sang initial angular velocity. And the initial angular velocity is 4 rad per sec. Ang t is equals to 3 squared. We need to, ang atong pangitaon subong is the value of the omega, or the angular velocity, and the theta, or the angular distance. So for solving the omega, or the angular velocity, we need to use the formula of alpha is equals to d omega, or the angular velocity, over the dt. Or we need to rewrite the formula to get the omega, or the angular velocity. So, ang atong gamiton nga formula is dw is d omega, or the angular velocity, is equals to alpha, or the angular acceleration dt, and integrating between the given limits. Ang formula gamit anang adan tas ang limit. So limits, so this is the example, or the formula. ng t, the alpha kagina, ang alpha kagina is equivalent is 3t squared plus 4. So substituting or calculating the ng omega minus 4 is equals to t squared t cube plus 4t. Then nang ihalinta ang negative 4 sa piyak to get the omega. So omega is equals to t t cube plus 4t plus 4. So, amo na ron sa ang equivalent sang aton nga or hindi pa na sang exact answer. Equivalent lang ng equation. So, how to get naman sang aton nga theta? We need to use the formulas nga omega or the angular acceleration is equals to d theta over the dt. And we need to rewrite this into d theta is equals to omega dt to get the to get the theta to theta to solve to get the exact answer. So theta is equals to t fourth over 4 plus 2 t squared plus 40. So, using that answer, ma-substitute ta ang t into 3 second. Ang equivalent sang t, every t is equivalent to 3 second. So, this. To get the exact answer of the omega, ng omega is equals to t cube plus 4t plus 4 ang kaginang answer. So, to get the exact or the answer gid nga aton nga i-substitute ang every t into 3 seconds. So, omega is equals to 3 cube plus 4 times 3 plus 4. Nang 3 cube is equals to 27. 4 times 3 is 12. You need to use the MDAS to get the answer. So, may ara na kita sang omega is equals to 27. Ang 3 cube is equals to 27 plus sang kagina nga 4 times 3 is equals to 12 plus 4 is equals to ang iya omega is equals to 43 rad per sec. So, to get the exact answer of the theta, ang kagina ng theta is equals to t fourth over 4 plus 2t squared plus 4t. So, we need to substitute every t into 3 seconds. So, theta is equals to 3 power of 4 over 4 plus 2 times 3 squared plus 4 times 3. 3 to the power of 4 is equals to 81 over, so i-divide into 4. Ang 41 is equals to 20.25 25. So ang 2 ang 3 squared 3 squared is equals to 9. So 9 times 2 is equals to 18. Nang 4 times 3 is equals to 12. So the exact answer of the theta na atong gingabinta na or gin-substitute na is 50.25 rad.